You want to become richer than Elon Musk, Jeff Bezos or Bernard Arnault together? Then listen, I'll tell you how. But be aware that you might have to travel a little bit. To be more precise, you'll have to leave the planet because the gold mines of the future are not on Earth. The thumbnail reveals it already. Today it's about mining asteroids, some of them so valuable you couldn't even imagine. But that's already enough introduction, so don't let us waste more time and let's go. First, let's discuss the benefits that space mining offers to those residing on Earth. Nearly every modern technological device relies on the use of rare metals, which are currently extracted with considerably difficult and in certain instances under inhuman conditions. That's because getting access to them is extremely difficult. The challenging access to those materials is primarily due to their often limited availability or widespread dispersion across the Earth's surface. Also, mining on Earth often has very negative environmental consequences, like destroying big parts of the surrounding nature and causing societal damage to the people residing at the mining areas. The mining process involves excavating large areas of land, which can result in the destruction of forests, wetlands and other vital habitats, leading to the habitat loss and the biodiversity decline. Space mining offers the potential to alleviate all the environmental and societal issues associated with mining on Earth. One big advantage offered by asteroids is the significantly higher concentration of valuable materials such as iron, gold or even platinum. Furthermore, it is possible to identify asteroids that contain these types of metals and directly target them for extraction. The only damage done to the environment through the space mining process is by the starting and landing rockets, which carry the rare metals back to Earth. This damage is compared to what present mining methods cause pretty small. If humanity gains access to abundant metal resources in space, eliminating the need for terrestrial mining, it opens up an entirely new realm of possibilities in space exploration. Spacecraft can be constructed on a much larger scale thanks to the potential for in-space construction, making the establishment of essential infrastructure in space significantly more feasible. Moreover, for those willing to invest in this endeavor, it holds the promise of the most substantial return in investment in human history, as these asteroids, as mentioned earlier, hold immense value. Psyche is an asteroid of the main asteroid belt discovered in 1852. It was named after Psyche, the wife of the Greek god Eros. It's made out of iron and nickel, which are on Earth rarely common materials. Nevertheless, the asteroid is worth about 10,000 quadrillion US dollars. For comparison, the world GDP in 2020 was about 87 trillion US dollars. That said the Forbes business magazine. The reason for the asteroid's value is its gigantic size. This abomination has a diameter of 250 kilometers and is one of the biggest objects in the outer asteroid belt. NASA has already planned a mission which will investigate the asteroid in greater detail in 2026 when the satellite arrives. Scientists think that Psyche 16 could be a core of a planet-like object that got ripped out of its hull in the early stages of the solar system. Psyche 16 is a Class M asteroid where the M stands for metal. Another example for an M-class asteroid is UW158, which has an estimated worth 5 trillion US dollars. It's compared to 16 Psyche very small, but it's made of platinum, which explains the value. But when there's such a high amount of money floating in circles around the solar system, why isn't it collected yet? Technically, it is possible to send unmanned spaceships to asteroids, like the Hayabusa mission, where it succeeded the first time to land a probe on an asteroid and bring back sample material. This was a purely scientific mission and not driven by any economic thoughts, which means that the financial losses were not important for the mission's determination of success. But of course, if the target is to mine an asteroid, it has to have a positive financial outcome, and at the moment we are far away from these circumstances. The trip to a M-class asteroid, the mining process and the return to Earth of the extracted material would be too expensive to be profitable, because the amount of metal that could be brought back to Earth would be extremely small. A solution for this problem is already in progress. The costs of bringing a kilo material into a low Earth orbit have sunken much in the last 10 to 20 years. You might know the Starship, which is SpaceX's attempt to make a fully reusable rocket and with it a vehicle that could bring humanity to Mars. Elon Musk describes this sort of rocket as the holy grail of rocketry. And he could be right, because it would reduce the price of space travel by a huge factor, and the spaceship isn't limited with the Mars to Earth distance. But how far could we travel with the Starship? To describe the action potential of a rocket, the unit delta V is used for delta velocity. First, we have to calculate the delta V of a Starship with the classical rocket equation. After that, we can calculate the amount of delta V needed to reach the asteroid belt with the delta V map of our solar system. For this calculation, I will take the data from the Wikipedia of 25/8/2022. The numbers might vary a little bit in the future because Starship is still in development. If you use the values for the initial total mass, the final total mass, and the specific exhaust velocity, you get an approximate delta V value of 6.9 kilometers per second, which is also the number Elon Musk tweeted to as the answer to this question. The future Starship, or the next fully reusable rocket of the future, which has the same or more delta V as the Starship, opens even more possibilities for operations in the asteroid belt if it runs on liquid oxygen and liquid hydrogen as fuel. Both can be produced from water in a not too difficult process, which is abundantly available in the asteroid belt in frozen form. We see that the speed would be enough to get to the outer asteroid belt, but when the rocket arrives there, it has to slow down to develop the mining machines, and then the build velocity is lost. But you could simply refuel the rocket there due to the sort of fuel required and fly it back to Earth with the extracted material again. So before you think that all of that would be an easy process because I described it in a more or less simple way, it's absolutely not. The whole story just works with many ifs, whens, perhaps, and also just with heavy infrastructure like fueling stations in space and a huge mining equipment on the asteroids. Many things that are not even being considered for development at the moment. At the moment, the biggest challenge is the far distance, if we consider the fact that our moon is the furthest point a human has ever been. Theoretically, is asteroid mining possible with chemical engines? But it would be much easier with electric propulsion engines. This type of engine has a much weaker acceleration compared to chemical engines, but the big advantage of it, the lack of atmosphere in space, allows the ship to accelerate for as long as there's energy left, meaning that the resulting terminal velocity is much higher than that of a conventional powered spacecraft. It's impossible to start from Earth with an electrical engine, but if the mining mission is started from space, every asteroid could be reached in a relatively short time. At the moment, the development of e-rocket engines is also not advanced enough for a commercial space mining mission, but in the past, small satellites already used electric propulsion. We see that at the moment there is no possibility to mine an asteroid in a relevant size, but the technical problems perhaps could be solved in the future so that humanity gets access to all the resources out there. But then another non-technical problem occurs. If everybody has access to a nearly unlimited amount of iron, platinum and even gold, what is it worth then? The value of a material is typically determined by how difficult it is to obtain. For instance, in some prison systems, cigarettes serve as a form of currency. Now, if on Earth the extraction of various metals would become significantly easier, the value of precious metals like gold or platinum per kilogram would decrease substantially. As a result, significant portions of the economy could lose their value, potentially leading to financial instability. These symptoms wouldn't occur in a case of a space gold rush. Currently, this scenario is quite distant to the reasons mentioned earlier. And even if asteroid mining were technically feasible, it wouldn't happen suddenly, and the materials could gradually make their way to Earth. This means that any decline in value would occur slowly, allowing the economy to adapt to the increasing availability of the metal. Consequently, there is no immediate need to fear a major economic collapse in the near future because of metal from the space. I hope this gave you a little overview about the topic. And as I said in one of the last videos, do your own research. That's always better than just listening to what somebody says on the internet. All my sources are linked below the video. If you enjoyed this video, make sure to like and subscribe, and I hope we see each other soon. Bye.